Okay, so thinking about the cantilever beam that we analyzed in that simple tutorial, right? What I want you to think about is how can you then use similar components within Comsol to analyze the beam that has the distributed loading that we've been analyzing in class as part of the project. Trying to remember where it is. So I have deflection shown. Let's see. Wish I could get a good view, but so I want to take and do a save as, right? And I want to revise this, right? Project beam. And so when you come back to geometry, we have geometry that has one block. Okay. And in fact, I wonder if, I think if I changed, I would get a better view. Haha. Okay. So I'm just going to change my orientation here a bit, but also I'm going to want to change my my geometry to match the project beam. So I'll modify that and build it. But I can also make something to consider. If I make multiple pieces of this beam, so for example, if I make the 750 millimeter section and then I add another block, I can start it at an X of 750 and make it a width of, I think the next component was 1¼ meters, and I'll match, I think depth was 20 and height was 10 in the one I have here. That's not true for the block, so you'd want to revise that. But now I have, right, now I have the first section, which is to the left of the simple support, the middle section in between the simple supports, and I can add another block, right? And I can put that starting at 2 meters and give it another piece there. So we'll go ahead and build selected, and now I have these 3 sections that I can use for different loadings. So when I come to my solid mechanics, I'm going to have to fix this fixed constraint because that's not right. It's not a cantilever beam, right? So I'm going to delete that. Or maybe I'll disable it. But I know I have a boundary load, but my boundary load is in the middle section, not on the edge, right? Let's make sure I got the right one. Yeah. And so I'm going to want to change the total force as well. I need to consider my material is structural steel correct, and I would need to add some sort of either prescribed displacement, so I could do that, for example, at here, right? This is a simple support. So I know that if I want, where are edges? I'm not sure if I can grab an edge here. So I'm going to try it. I think I found edges that I might be able to add, so I can look at edges and consider a prescribed displacement here of this edge. And I want it to move 0, right, in all 3 directions. That's one way I could consider it. I can put a reaction load there, but there's a potential that the reaction load won't hold it in place. I could make another small boundary here. Not boundary, domain, by making a very small block in between each of these that might be easier to fix. So there's a number of different ways that we can simulate this. I'm going to go ahead and find my other boundary though. So both of those would be 0 displacement, and I have one boundary load. I don't think it's quite right, but I'm just going to do, a quick. I also didn't reconsider like which direction the boundary load is for the direction of my beam. But, if I just wanted to compute, and I haven't put my concentrated loads on, that's something else I need to consider. But certainly it's enough to get started with. So I want you to consider how this works, and then compare your von Mises stress in this simulation to what you're getting out of your hand calculations and your deflection, right? So that's my stress. Solid mechanics displacement field. I think I'm in the y component at the moment, so let's plot it, right? So I can see the displacement. So what happens when I apply some counterbalancing loads? So that's the idea here. And also think about how you can get out. So we'll look at things you can export. So I can export data sets. I can export, let's see if I, so when I come here to the results tab, data, I can export data, and I'm just going to select, so solid mechanics, I can grab my displacement, and then I can grab, if I wanted to, I could grab my strain instead, right? So I could grab my principal strains, or I could grab my, let's see, stress, von Mises stress, oops. I did that wrong. Solid mechanics displacement, heavens to Betsy. Oh, here we go. Okay. I just used I needed to use the plus. I did it wrong again. Okay. There we go. Okay. So now I can export it to a text file, and this will be test.csv, and when I open that, you can see, right, so I've got, this is along the beam, and that's my x location, y, z, and then this is my von Mises stress and my displacement. So I can find my maximum stress here in my beam to compare to what I got out of my simulation data. So I can see my von Mises stress, a maximum here at the supports and a secondary maximum in between. Again, remember that this is without my concentrated loads. Something to consider is, it might be easier to work outside of Comsol once you have your data. Okay, I'll wrap up. So there is flexibility in how you use Comsol and how you apply your loads and set up your boundaries. And so play around with the settings and see if you can get what you think is a solid simulation so that you can compare to your data.